Hey y'all. Well, we're back at it. Let's get this going. So, what I want you to see on this one is we're going to do a binomial distribution. We're going to use the calculator to do it, and I'm going to use an on-screen calculator to show you this. So, in this example, we have according to the Gallup organization, 65% of American adults or adult Americans are in favor of the death penalty for individuals convicted of murder. In a random sample of 15 adult Americans, what is the probability that A, exactly 10 favor the death penalty, and B, no more than 6 favor the death penalty? So in this case, N here is going to be 15 because there are a random sample of 15 obtained. That is the total number of people that they're going to ask, and they're going to figure it out. So the probability that they favor the death penalty here is 0.65. Okay, and so in case 1 for part A, we have x, the random variable, being equal to exactly 10. So this is when you ask 15 adults and exactly 10 of them say, yeah, I favor the death penalty, and the other 5 say, no, I don't favor it. So if we're going to do this, we can use the calculator. And so I'm going to show you how to do that. So we're going to pull it up real quick. Some things to keep in mind. We're going to push second. We're going to push vars. And then we're going to go to where it says binom PDF. We want PDF because this is not cumulative. I forget what P stands for. I think I've told my students in the past that it means particular, just so that they kind of remember, oh, it's for a particular instance. So we're going to use that one. We're going to push enter. Okay, the number of trials is going to be 15 adults surveyed. The probability of success is 0.65. And the x value, we want exactly 10, so we're going to put 10. Paste. Okay, we get here, we enter it, and this value is P of 10. Let me see what I can do. I want to be able to see that because I don't want to. P of 10 is equal to 0.2123. So that means about 21.2% of adults, or I'm sorry, that if you asked 15 people and 10 of them said yes, 10 of them would say yes about 21% of the time. Okay. So let's do it again, but this time we're going to use the other factor. It says no more than 6. So that's when x is less than or equal to 6, because if it's no more, if it's equal to 6, that's fine. If it's 5, 4, 3, 2, 1, or 0 of them saying that they're okay with the death penalty, that would fall into this category. So now we're going to use the calculator again, so let's go ahead and clear that. A quick way we can get to it is, sorry, we don't want to use that because this one's going to be a CDF. It's going to be a cumulative of everything from 0 to 6. And so let's go ahead and go to second vars. We're going to go back to binom CDF this time rather than PDF. We're going to push enter. 15 trials, 0.65 probability that it's right. And then paste x value here is going to be 6. Okay, so the reason it's 6 is because remember in our slides from earlier I said that the calculator always does less than or equal to. Well, this is a less than or equal to problem, so we're just going to enter exactly what it is. If it was strictly less than, rather than put 6 here, we would put 5 because we need to do one less so that we don't include 6 in that set. And we don't want to if it is strictly less than. So we're going to go ahead and calculate it. We go ahead and paste it. We go ahead and enter it. It tells us that P of x being less than or equal to 6 is equal to 0.0422. Okay, so if we have that, that's a 4% chance, 4.2% chance that that if you ask 15 people, either 0 people, 1 person, 2 people, 3 people, 4 people, 5 people, or all 6 people say that they do not favor the death penalty. Or I'm sorry, they say they do favor the death penalty. Excuse me on that. Okay, so last but not least, let's do one more problem. Let's say, for instance, that we want the probability that greater than 6. Anything bigger than 6 is okay. Favor the death penalty. Okay, so if we're going to do this, then we can do it two ways. We can use the calculator. Remember, if we're going to use a greater than, we need to do 1 minus binom CDF. Okay. In this case, it's NPX because greater than 6 is going to be anything 7, 8, 9, or 10. 10, 11, 12, 13, 14, or 15. And so we'll be okay if we do that. So if we do this, I have a feeling we're going to get around 95%. So what I'm going to do is I'm going to go and push second. I'm sorry, no, we're not. We're going to go ahead and clear that. We're going to put 1 minus second vars binom CDF. 15 trials, 0.65 and 6. That's fine. We're going to push enter. And we get equals 0.9578. Okay. Now, I was able to predict that it was going to be about 95%. What I did was, rather than actually do the problem using the binom CDF, calculation that we would use here, I used the complement. I used 1 minus the probability that x is less than or equal to 6, because those are all of the values. So if you look at them, here's P0, add P1, all the way to P6. Keep adding, add P7, add P8, and then go all the way to P15. Well, we calculated the probability of all these. This was equal to 0.0422. And then the whole thing should add up to 1, right? 100%, because either 0, 1, 2, 3, anywhere between 0 and 15 people are going to say that they favor the death penalty in any given sample. And each one has their own probability. And so if I do 1 minus 0.0422, I get that 95.78, which is exactly what we got up above. Okay. Oops. And so that was my reasoning behind it. So sometimes it's beneficial. You can still use the complement rule that we learned in the past. You don't always necessarily have to use the binom CDF if the question is right. I hope this helps. I'll be making more videos soon.